Hello everyone, my name is Jakub and I'm a software engineer. I work at SAP Concur for almost 5 years and I started actually as an intern, and for 4.5 years I was a member of a backend team that took care of multiple services. You may know, for example, expensive or mobile push notification service. Since this year, since January, I am a member of Concur Labs team and I'll be teaching you today and the following lesson. So let's get started. Our two lessons are going to be a bit different from the previous lessons. In previous lessons, you learned about Kotlin as a programming language and learned the basics, how the syntax looks like. Today, we are going to implement our small project, which is going to be an HTTP server. And we will hopefully implement several endpoints, and we will continue working on this project in the following lesson. So let's get started. This is our GitHub, where you can see what our lesson is going to be about. Let's start with useful links. We will be implementing a Kotlin server using a framework called Ktor, and you can find all the information you needed about it on Ktor server reference, which is a page like this. It has a bunch of items and it walks you through all the implementation details you need. I highly recommend to look at this page in case you get stuck at something or you just want to learn something new. We will also use that page to generate our Ktor project in the few moments. And before we start, we actually need to know a little bit of theory. What are we trying to achieve? So what we want to do is to allow two machines to communicate with each other using the internet. For that, there are protocols. We will be using the most common one, that it's called Transmission Control Protocol, Internet Protocol, or you may know it as TCP/IP. This protocol handles all the communication between those two actors, which are called client and a server. Server passively listens for incoming connections, and client connects to a server. TCP/IP handles the connection for us. It ensures that the handshake is done, and it handles retransmissions if something gets wrong. It detects errors. So we don't have to worry about anything like this. But in the end, what is sent through TCP/IP is stream of bytes. This stream of bytes should have some structure, and that structure is defined in Hypertext Transfer Protocol, or HTTP. We don't have to strictly follow it, but if we don't, then we cannot expect other applications to understand what are we trying to do. That's why the standards are for and are widely used on the internet. You can see here the example request. It consists of method, path, protocol and its version, and some headers. In this case, header host, which tells us which server we are trying to reach. So in this case, we want to go to google.com for resource at index or root using get method and HTTP 1.1 protocol. The server may respond to us in a similar manner, saying the protocol and its version, the status code, and verbal representation of this status code. In this case, we are using HTTP 1.1, and the response was okay. We got status code 200. How do we actually make these requests? Well, we can just take this text and send it to the server using, for example, Telnet. But that's not very convenient. So for that, we have tools. The most common one, you know probably, is web browser. When we go to google.com, we make the request as I shown you. Of course, there is something else, for example, HTTPS, and we are sending a bunch of headers that help us identify who we are. But in the end, it's pretty similar to this. We can also use other tool, for example, CURL or curl. Let's say we want to go to google.com and let's have it verbose so we know what's happening. Here we see that we were connecting to Google, made get HTTP11 request. We sent user agent header. It says who we are curl, and we send accept header, which means what kind of content do we accept. This says we accept all kinds of content. And the server responded to us with status code 301 moved permanently, and is telling us that we should use this location. So now if we try to make similar request on this location, we actually get a code that generates the page we want, the page we see here. So curl is awesome tool, and I recommend you to get familiar with it. But I also want to show you Postman, Postman is a tool that I very much like. It's free, and it helps us save and create collections of requests that are easily shareable with others. So let's go to google.com. And we can see that we got response that in the end generates the page on the browser. So this is how we make HTTP requests. In my lesson, I will be using mainly Postman because of its convenience. So I would like to recommend you to use it as well. You can get it on a page postman.com and download it there for free. During these examples, I mentioned a few things. So let's dig a bit deeper into those. I mentioned a method. Methods are defined and should be followed in order to understand what the server does and what can we expect from it to do. The commonly used methods are get, which is for retrieving resources. For example, going to google.com was get. This method is safe, which means that no resources are changed or should be changed on the server. We can make this request several times, and never should we change any resource on the server. Then we have a method called post. This one is for uploading our payloads, our data to the server. And then we have commonly used methods put and delete. And these two methods are idempotent, which means that if you do these requests 5 times one after another, the response will always be the same. So if I if I make a request put on resource A, something happens. If I make it the second time, the same thing happens. For example, I can use put to update my resource, to change one of its properties. And if I do it 5 times, the property will always change to the same value. The same for delete. If I delete property A for the first time, it gets deleted and I get a response, it got deleted. If I send it for the 5th time, I will still get the response, it got deleted, even though it wasn't already there. To quickly analyze what actually happened on the server, we use status codes. These are represented by values between 100 and 599 and are standardized, such as that 100 response status codes represent some information that our client might use. For example, 100 says continue. This tells the client that it can send another part of the body or the payload of the body. 200 responses represent successfully processed requests. So you may know 200 OK, which we saw here, 201 created, 204 no content. All this says that the server successfully processed our request, and based on this, we see that we just got information that it's okay. We got information it was created, This can and should have some payloads with it, for example, with the ID of newly created resource, or 204 no content, which again says, I processed it correctly, but I have nothing to tell you. The payload of the response is empty. 300 status codes represent redirection. We've already seen 301, which means move permanently. All requests should be directed to different address, as we saw in our Curl example. 400 response status codes show that the client made an error. This can be 400 bad request, the request was incorrectly formatted, 401 unauthorized, you may know 404, the resource was not found. And funnily enough, there is 418, which says I'm a teapot, which was an April Fool's joke. And it shows us that even though we are communicating machine between machine, the protocol was created by humans and we have fun. And finally, 500 status codes say that there was an error that happened on the server. 500 is internal server error. 501 says the item or the thing you are looking for is not yet implemented. The difference between these two 400s and 500s is mainly in that 400s should not be retried by a client unless the payload or the request itself changes, because it will always fail. If you made a request that resulted in bad request and you make the same request again, it will again result in bad request. You need to fix your payload. On the other hand, server errors are happened on the server, and if you try later, you should get successful response. For example, the server may now be dealing with huge payloads, or that it cannot process in time, or it can have some networking issue, it cannot communicate with it upstreams or downstreams. So if you wait for 1 minute, 30 seconds and try again, you may get successful response. So this is just the surface of what we should know before we start to implement the HTTP server. And now we are ready to do it. We have a bunch of tasks. We are going to go through these 6 tasks, and eventually, if you have time or if you are interested in it, I highly recommend you to implement also these optional tasks. So let's start with the first task, which is let's launch Ktor project. Ktor project actually expects some structure, some files, and we can create it manually, but try to do that if we have some tools that do it for us. Awesome tool is a plugin for our IntelliJ IDEA. Just go to Marketplace and search for Ktor. Click on install, and once you have it installed, it will probably require you to restart IntelliJ. And once done it, you can create a new project. And on the left, select Ktor. Leave everything unchecked, and if you have anything checked, just uncheck it. For our example, we need just a bare empty server. So have it like this, click on the next. Let's set up some artifact ID and group ID. Let's go it Concours Academy, and this is a lesson 9. Let's not deal with version, we don't need it now. Let's save this project to lesson 9. And by clicking finish, we'll create the project. So let's do it. Now it will need some time to import, to build the project and import resources that we need. So in the meantime, there are alternatives how to start a project. We can go to Ktor generator, which is the same tool basically that we used, but it's online. Again, we can just uncheck everything, set up our group and name, and by clicking build, it gives us a zip file which we can download, unzip, and open as a new project in IntelliJ. And finally, if you don't want to do this, you can just use this archive in our GitHub repository, and it's the same one that I will be using. Again, you will unzip it and open it as a new project. So once we have all this done, let me just close this. We are ready to build and start our first project. For this, we can go to source and open application KT and run the application for us by clicking on the arrow and click on run. This will build the project for us, and after a few seconds, it will start it. Here we can see that the server is starting, and let's check out the logs. Log with level of trace, so very low level log, and we will skip it. Eventually shows us the configuration that the application starts, so we don't need to deal with it now. Then we have information that we have an inactive automatic reload, which is fine. We don't need it for our purposes. And finally, the log tells us that the server is responding on HTTP 00008080. If we open this in our web browser, we see that nothing happened. That's actually not entirely true. We can open network and refresh this page, and we see that we got GET request on our server for /resource, and we got response 404, which, if you remember, is not found. That makes sense because our server is completely empty. It doesn't have any resources implemented. Well, let's actually fix that, right? This is going to be our second task. Let's create hello world endpoint. This is going to be get endpoint, which just returns some string. So let's do it. Ktor works that it uses multiple features. Some are already part of the server and some need to be installed. A routing feature is the one that takes handle about resources. This one is pretty core feature of all servers, so we don't have to install anything, and we can implement, or we can start using it just by saying routing and implementing first route. Let's say that we want to create get endpoint on slash hello underscore world. We need to body and import this. Now we are already part of this endpoint, and whatever we implement here actually executes once we go to that get / hello world endpoint. Let's not do anything here except of responding call dot responding and saying hello world. Call is an object that lives during the execution of the request. It cannot be referenced between two requests. And it's available in everyone. We can set the response here. We can read the request here. We can store some temporary variables here. For now, we've implemented the first endpoint, and we can restart the server. And once again, we can go onto our server and add hello world. Voila, we got a response, which is 200 and says hello world. Awesome, so we got our first endpoint. We can make this request using CURL as well. CURL, let's say verbose HTTP /000 on port 8080 / hello world. We got the same response. Hello world, exclamation mark. And finally, we can make this request in Postman as well, just on this address. Hello world. What I may mention is that 127.0.0.1 is the address of our localhost, and our server listens on 0.0.0.0, which means it listens on all addresses. So this request reaches our server as well. 8080 is the port that the server is listening to. For HTTP, the standard is 80. For example, HTTP Google.com is equal to Google.com colon 80. Sorry. So we use 8080 because 80 is already reserved usually and should not be used by custom application. It can be, but it's not a good idea because system may have some resources there. So this is it. We got our first endpoint. Congrats. Let's move on to third task. Let's send some data to our server. Now, as I said, there are multiple methods. Get method is or should not contain any payload. It's not forbidden. The payload is optional, but usually when you ask for some resources, you don't really want to store something on a server. So you just ask for that resource. But that being said, we can still send some parameters to our server. So let's implement get slash hello. Now, the first way how to send some parameters is using URL. We can say slash hello slash name, and now we will use URL parameter called name. We can take this parameter and store it into some variable. Let's call it name. And we can access this parameter again from our call dot parameters and name. Now we can use this variable in our response. So let's respond with hello name. Let's restart the server. And try hello Jakub. Wow, the server says hello Jakub. Awesome. Now the second thing, and very commonly used how to send parameters to the server, is using query parameters. We can access those by saying, let's create some variable, and let's say call dot request, because it's part of the request, query parameters. Let's ask for a specific one. Let's call it title. This way we can rename the variable to title. And again, we can say hello title name. Let's try again. Query parameters are added by adding a question mark, name of the parameter, title, equals, and whatever we want. In this case, MR. Now we got response, hello, Mr. Jakub. Awesome. But what happens if I omit the parameter now? We see that the server processed it correctly, but instead of saying Mr. or nothing at all, we got null. This is probably not something we want. That's because the parameter was not found, and the default value when the parameter is not found is null. And that null is stringified when we create this response string. I would like to introduce you to Elvis Operator. It's called Elvis Operator because it looks like Elvis emoji. which says that if the expression on the left is null, then use the expression on the right. So in this case, if this is null, let's use empty string. That way, this will be hello space empty string space name. So now we have two spaces here. This is probably not something we want. So again, this can be easily avoided by introducing it to this operator and saying plus space. What this actually does, it resolves this expression, makes null check. If this is null, just use null. And that way it will jump to this Elvis operator and use empty string. And if it's not null, apply plus empty space to this resource, to this variable. So now we can remove the space here and we can try again. Let's first show that we did not break anything. Hello, Mr. Jakub, awesome. And let's remove title. Hello, Jakub, single space, awesome. So we got our second endpoint implemented. So this is how we usually send the data to the server using get. We can also, or this is actually what we showed here. And now we can simply continue with implementing post and send the data in the payload body. So let's do that. As with get, post, endpoints are implemented by saying post, the path. So let's say slash hello, and let's do the import. Now we can implement the post. Reading the value of the payload is again pretty simple. Let's store it in some variable. Let's call it a for now, or we know what's going to be there. Let's call it name, and let's check call. And here we have a method called receive text, which reads the payload as a text. And again, as we did multiple times, you can just say call respond with hello name. Now, making a post request using web browser is not as simple, so I will switch to our Postman, and I have the request prepared here. The payload is just a raw string, raw text saying my name. So I'm not sure whether I restarted the server, so let me restart once more. And let's send the request. Hello, Jakub, awesome. So we send the data in the payload body. But what happens if we don't send anything, if we send empty body? This is probably not what we want, right? Because empty body is treated with this receive text as empty string. So let's implement simple check. If name either is empty, but I prefer to be more specific and saying if name is empty string, then do something else. Well, what should we do? I would say that the client used our endpoint incorrectly. So I would respond with an HTTP status code, with HTTP status code that informs the client, hey, you did something wrong. So let's say bad request. Now let's run this and check what actually happens. We sent the request and we got 400 bad requests, which is good. That's what we expected. Well, let's see what happened on the server side. And here we see that the server exploded. there was an exception, and it says response has already been sent. That's because the processing of the endpoint of this request started on this line, then it handled this if branch, went inside, responded with this, but it did not end the execution. It followed onto the next line, jumped out of if, and it got another response. So we tried to respond twice to a single request. That's obviously not allowed. So we need to end the execution here. We could end it by saying else and have this branch executed only if the first one is false. But I want to show you how to actually respond with using the return at post statement. This says return after the execution of this block up to the post of this one with this value. This means that the execution ends here if it goes into the branch, and this is not executed at all. So let's see that. Here we see we still have bad request and no exception here. Awesome. Let's check whether it still works. And it does. So we implemented another thing. So this was just playing with some endpoints. Now we know the basics, and now let's create something that's actually useful, that actually does something that could be used on the server. Let's create a resource on the server. Let's call it expense because we at Conquer deal with expenses. And let's store it somewhere. Usually we would store it into the database, but for now, let's store it into the file because we will not have huge traffic, so there's nothing that would make using file unreasonable. We will use these code snippets, so let's do this. Let's implement post at /expenses, and in its body we will want to read the expense. But what is actually an expense? I've already prepared something, and this is what I would like the expense to look like. I would like it to contain some amount, which is a float or double. I would like the expense to have some currency. The currency cannot be any string, but it has to be some approved string, some actual currency, in this case USD. And let's add some custom string, for example, vendor, who may be something from The Simpsons, Ricky Mart. So this is the object that represents expense. On the server side, we would like to process this. By the way, this object is JSON, and this, the request also tells us that it is sending content which is of type application/JSON. We would like to map this JSON in a string, JSON in a string, onto some of our object inside our application. First, let's create expense object, or expense class. This is going to be data class, and it's going to contain some fields. These fields are going to be amount, let's have it as float, currency, and let's have this as currency as an enum that we will implement later, and value vendor, which is going to be some string. Now let's implement the currency. Enum class currency, and allowed currencies are going to be Czech crown, American dollar, and euro. Now we need to let the server do the serialization to map the string onto our class. For this, we are going to use Kotlin Serialization Library, which first needs to be imported into our project. To do that, we need to do 3 tasks. We will need to modify build script dependencies, where we need to add this. We need to modify our dependencies of the project right here, and we also need to say that we want to apply plugin Kotlin X serialization. Okay, so this is it. Now we can click on the elephant and refresh or rebuild the project. And now we can use this serialization or this library. Well, our Ktor is able to do the serialization for us. We don't have to do it manually from the string. For that, we need to install a feature. This feature is called content negotiation. Install content negotiation. And we need to specify that we want to use JSON and say that for JSON, use JSON default JSON configuration, and we want to change something in here, and I will let you know why in a few seconds. So we take the default configuration, we copy it and change pretty print to true. Now let's do the import, and we want to import this thing. Now we also need to specify for which content types we want to apply this serialization. So we want to use content type, and out of all available content types, we are going to select application.json. So now this means whenever we get to deal with application JSON content type, we will use this serializer to either read string and parse it onto our objects, or to parse our objects into string. And when we do this stringification, we will use pretty printing, which means that the response is going to be prettily indented for easy human readability. We'll see what that means in a few seconds. For now, we need to let the Ktor know that this class is actually serializable with Kotlin X serialization. Now we can read the body. Let's read the expense from the body. Why not? Let's specify even this. And what is it going to be? Well, it's going to be call.receive. This takes the payload we got and uses serialization to store it as an expense object in our memory of our project. So this is it. What we can do now? Well, we can also implement some response. Let's say we want to respond with some status code and post. We are going to use this endpoint to create new expense. So let's use create it, and let's respond with somebody as well. Here we will respond with map of, saying that we want to have key called ID mapped to ID in the expense. This ID is going to represent, or would represent, the expense in our database. For now, we don't have database, so let's just randomly assign ID to the expense. This is simply just modifying the expense as value ID. What is it going to be? It's going to be int, integer, and it's going to have a default value of random dot next integer from 1 to 100 inclusive. Right? What it doesn't imply. Give me a second. Oh yeah, it's missing. Come on. Okay, wait. Sorry. So now we generate the ID. It doesn't need to be sent to us, and we let our client know what the ID is. So let's try to run this. Awesome. The server processed the request. It told us some resource was created, even though it's not yet true because we did not implement it yet. And it told us that the ID of the created resource is going to be 44. Cool. So now we probably should store the expense somewhere. As we said, we will be storing it in a file. So I'll show you how to work with files. It's nothing very difficult. You can just create a new variable. Let's call it F, which is going to be file, and the file name is going to be expenses.txt. Let's do the import file from Java. Now we can pretty simply just store our object there. This could be done by storing it as a string. If we implemented toString method that's easy for machine or humans to read, or we can just parse the object and parse or stringify it into the string. So let's do that. The stringification can be done by let's first create JSON object, which is going to be JSON using default JSON stable configuration. Stable. And now we can say JSON dot stringify. We say what serializer we want to use. In this case, we want to use expense serializer, which is implemented by adding the serializable annotation. And which object do we want to stringify? Expense. Now we have it as a string. We can store it in a variable, or we can say file dot write text, and you can write this there. So now we will have created expenses.txt file, and it will have stringified expense stored. This expense will now contain even the ID because it was generated when we were creating the expense object. Let's try that. We got expense with ID 11, and here we see expenses.txt, and here we have the JSON stringified object powers with the ID and all the values we were expecting. Okay, this is cool, but this is expenses. It probably, we want it to contain multiple expenses, right? Not just single expense. So it's simple. Let's just store our expenses there in a list. There's nothing difficult to do in this. We just need to tell the serializer that we are going to be serializing a list. And we need to create a list of expenses. List of expenses, which it contains now just one expense. Just quickly run it. The file is going to be overwritten. expense number 24, and expenses just 24, and it's in a list. Okay, well, I said the expense is going to be overwritten. That's not something we want to do, right? We want the expenses to be appended. So for that, we need to first read the database, read our text file, and append our expense there. Reading the file is, again, pretty simple. You can just say f as a file dot read lines. This will read all the lines. We will have just one line, but just for the sake of it, let's say that we want to join lines to a string. So now we have, let's call it lines. Okay, so this is a string, a single line of string. Well, we want to parse it onto our expense now, so we can see what's actually in there. So for that, we will use our JSON. And this time we will not use stringify, but we will use parse. And we will parse our expense serializer. It's going to be list. And we will read this string. So now this is actually not lines, but let's call it stored expenses. Fine. Now we need to add our new expense. It's pretty simple. Let's say let's say vol value newly stored expenses is stored expenses plus our new expense. And let's write this new thing, this new list into the file. Nice. So let's try this code. We can send expense. We got expense 18 created there. Let's send another one, expense 34, and let's check the expenses. We see that there was previously the expense 24. It did not get deleted, which is what was expected. We got expense 18 and finally expense 34. So cool, we can now store expenses. Well, what now? What if I just want to show you how to handle some exceptions or some issues? What if the expense that was sent by the user is incorrectly formatted? What if it doesn't have a currency? The server cannot handle it. It says there was an error during processing, and we see it exploded with an exception saying currency is required, it was missing. Well, there's nothing we can do about it, because if the currency is missing, we cannot create an expense, right? So let's create a try block, which says try this line of code and catch an exception. We could catch the exception called missing field, but for simplicity, now let's catch any throwable exception. And if this happens, what can we do? Well, all we can do is just stop the execution and say this was a call that respond. This was a bad request. Okay, so now we handled this. The expense needs to exist outside of this try except block or try catch block. So let's create it here. Expense is going to be expense, and it's actually let's do it like this. Let's assign it here. Okay, so now we have some a validation check and handling of incorrect payload. Cool. Now, when we start the application, we try to read a file now. Previously, we immediately wrote into it, but now we try to read. What if this file does not exist? We should also handle this situation somehow. So let's say try, and let's include as little as needed. So let's include this. And again, for simplicity, just catch any throwable and say if first let's say that stored expenses is actually let's do it like this. Stored expenses is what comes out of this try catch block. It can be sorry, it can be this, or if it explodes, it can just be empty list. Now this should be fine. Let's just, for our understanding, specify that this is really a list of expense. This is needed for this part of the catch block because it wouldn't know what kind of list we are trying to create. So this is cool. Let me just check that we didn't forget anything. And it seems like we didn't. So awesome, we have our endpoint that now stores expenses. Let's try it. Let's delete this file. And first, let's create some valid expenses. We got ID 41, 76, 77. And let's try what happens when it's incorrect. Bad request. Awesome. What happened here? We see no exception. Everything was handled as expected. Cool. We got post endpoint. So we have just last task ahead of us. And this is read resources on the server and send the list to our user. That's actually pretty simple because we've implemented this part already. Let's just create get /expenses endpoint. And why did I say we implemented it? Because we did. It's over here. We can just copy from here to here. We should probably create a function out of this, but let's not deal with it now, and let's have repeated code. So we read the file, use JSON serializer, read the file here. We probably, if the file does not exist, well, it can happen that we will call expenses before we call post, so this catch kind of makes sense here, although responding with 500 server error is also somewhat correct because it's server error. And now just respond, call.respond with these stored expenses. What I probably didn't mention is that this feature not only reads the payload, but it also helps us serialize our objects here and here into JSONs. So we don't have to deal with it by manually saying JSON stringify something, something. So let's try this. We already have some expenses created. Let's create some more. And let's now do the get expenses. And we have this bunch of expenses already created, 1, 2, 3, 4, 5. If we create a new one, it will be added there as well. Here it is with ID 1. So cool, we implemented our first server. This server runs several, or provides several endpoints, and it even creates, accepts payloads and creates file where it stores it and reads it from. Another tasks that I would recommend you to do to practice what you learned is to update the expense by the ID. For that, you could use approach of reading the ID from path. Update is usually done with put or patch method. And you would read the payload as we've learned it, for example, even as entire new expense. Then you would read the file. You would go through all the expenses that already exist and find the ID you want to modify and just replace it with a new string or new object and stringify it and save it. Similarly done is the delete. Again, read all store expenses, find the ID you want to delete, remove it from the list and save the list. Finally, you could read a single resource. It's again reading its get method, which this one is delete, by the way. This is a get method that reads the file, finds the expense you're looking for, and returns just the expense, not a list of expenses, and does not modify anything because, as we said, get is safe or should be safe. And finally, you can even try returning some HTML because this is just a text. You can format it as an HTML if you want for the browser to display it more user-friendly. Why not? And we've already talked about what we want to do next lesson. There was an offering of 3 options. The first one was learning how to package our server and deploy it somewhere on the internet. For that, we would learn how to create a Java archive. We will use Heroku platform, which is awesome free platform which offers free tier that I used to deploy my Python server, and it offers even Java or Kotlin deployment. The bad thing is that it requires registration, but we can use 10 minutes email if you don't want to give them your email address. And it's sufficient for our purposes and your subsequent experimentation. And what will be awesome is that we will be able to call this server that you deployed from your application, from your client that you're going to implement in the following lessons. So this is really cool, but it includes a little bit less of Kotlin programming. The other option was to play with AWS, where we would get familiar with commonly used services, simple storage service and simple queue service. We would provide you with a key and secret to our AWS account, but we would have to limit this key's permissions and we will have to deactivate it afterwards. So if you would choose this option, you would probably not be able to experiment with it yourself because we cannot give you our key, and you would have to have your own AWS account, which is usually paid, even though free trial is somewhat available. And final options was to just talk about more Ktor features, because what we just showed you, or what I just showed you, this just scratched the surface. We can talk about authorization, status pages, which are used for handling exceptions, logging. We don't have any logging there. If exception occurs, we don't know what actually went wrong. So there is a lot to talk about, and we chose that on the next lesson, we are going to talk about packaging and deployment. So if you want to be prepared for this lesson, I highly recommend you to check out Heroku, and you can create your registration there, so to have no problems using it. That's it from my side. I thank you very much for your attention. I hope you enjoyed this lesson, and I'll see you next week, where we will be talking about packaging and deployment. Have a good day. Bye.